Okay, so converting between radical form and exponent form. And the only reason I'm still doing these videos is because people are randomly absent. Hi, Cesar. Okay, so what is the name of this symbol? What is the name of this symbol? What do you call this symbol?
Square root.
The squared root symbol, right? But the actual technical term for it, because if you think about it, the word squared applies to what exponent? Exponent only. Two. Now, when we're converting radicals, when we're converting from radical form to exponent form, it could be something other than a 2. It could be 3, 4, 5, 6, or 7. So this is actually, the technical term is that this is your radical symbol. It's your radical symbol. Yeah. Now, what's under the radical symbol or what's inside the radical symbol is something you should already know. This X right here is considered our what? What part of the power? This is our base. And the number or the variable that's in the upper right-hand corner is the exponent. Is the exponent. Remember, together they make a power. Base with the exponent makes a power. Now, the name of the number that we have here on the outside, that is something you don't know yet. That is called the index. Index. Now, typically, you don't see a number in this spot. And if you don't see a number in this spot, that means we're taking the square root of a number. And square root, we just covered it, means that we're taking, that means squared means what? Exponent of 2. So unlike whenever we're missing an exponent, we put a 1, we fill it in with the 1. Here in this index spot, if there's no number here, it is understood to be 2, meaning they do not have to put the number 2 there for you to know it's there. Just like the exponent, they don't have to put the exponent of 1 for you to know that it should be there. If there's no number in the index spot, it is considered to be the number 2. And all we're going to be doing is converting these powers from radical form, from them being under the radical symbol to them being an exponent form. These are 2 different ways to write the same thing. Both of these, when you simplify them, will give you the same answer, and I'll show you what I mean by that in a little bit. So when you're converting from radical to exponent form, think inside over outside. Inside over outside. Which number do we have inside the radical? The exponent. Which number do we have inside of the radical? The exponent. Which number do we have outside? The index. Inside over outside. Exponent over index. Inside over outside. Because right now, when you convert to rational exponent form, your exponent will be in the form of a fraction. Okay? Turn the page when you're ready, or flip it. All right. Let's start off something simple. The squared root, square root of x. When a power or when a base does not have an exponent, you fill it in with what? A base with a 1. If there's no number on the radical symbol, you put a 2 as your index. So when we convert this into exponential form, base stays the same. Your exponent turns into a fraction, and it's inside over outside. Inside over outside becoming what? 1 over 2, 1/2. Both of these are the same, will give you the same number, will give you the same answer, and you'll be able to see it with this one, okay? 36. 36 does not have an exponent, so you put an exponent of, and what do you put on the outside? Becoming 36 to the power of 1/2. Your exponent is 1/2. Inside over outside, inside over outside. Now, I want you to see that this is two different ways to write the square root of 36. So get your calculators. You need to be able to understand that this is just two different ways of writing the same thing. So even without the 1 and the 2, type in the square root of 36. Everybody knows how to find that square root symbol?
Yes,
Second x squared. You have that radical symbol in blue, so you do have to press second and put the 36. What number does it
6.
give you? 6. Okay, so I'm going to write a 6 here.
That's how we put the radical thing in there?
You just said it. Second x squared. Oh, put 36. Type 36. Enter. Okay, next, let's try typing in 36 to the power of 1/2. So 36, how do I bring up that little box?
The thingy right here.
What's it called?
I don't
Like a
know.
vegetable.
A vegetable?
Carrot. It's a
Oh,
carrot. So 36 to the power of, that button's right under clear. And now, how do I put in a fraction?
alpha y equals
Alpha y equals. So I'll put 1/2.
6.
Press enter. 6. Both represent the square root, just two different ways of writing it.
We can pick one of those?
What's up?
We can pick one of those?
You'll practice going both ways. Right now, we're going from radical to exponent. And on the other half, we'll go from exponent to radical. Ready? Cubed root. Cubed root. X does not have an exponent, so I assign an exponent of,
1.
and it becomes x to the power of,
3.
not 1/2,
1/3.
1/3. The index is 3, inside over outside, 1/3. Look at number 4, similar, but not the same. So 27 needs an exponent of,
1.
and when we change it to exponential form, it becomes 27 to the power of
Power of 1/3.
1/3. Okay, so I want the left side of the room, take the square root of 27. I mean, the cubed root of 27. Actually, there's a faster way to get to the cubed root. So never mind. Everybody do it together. Press math. Notice option 4 gives you that specific cubed root, but option 5 will allow you to put any number in front of the radical. And we're not going to do this for every single problem. This is just so you understand that this is two ways to write the same thing. But go ahead and press number 4. That's my cubed root. And I'm going to type in my 27 and you get your 3. Now put 27 to the power of 1/3. What do you get? You also get 3. Same thing. Both of these represent the same thing, just different ways of writing it. If you have a fraction in your exponent, you're most likely taking the square root, the cube root, or the nth root of something, okay? Let's look at number 5. You're not always gonna see a number. If you don't see a number, it's a 2. You could see a 3 that has a specific name, cubed, but then you could also see 4, 5, 6, or 7. If it's 4, it's pronounced as the 4th root of x. So we're actually just going to write it for this one. That way you know how to pronounce it. 4th. Let me make it small. 4th root of x. Or example 6, there's a 2. The 4th root of 2. The 5th root of 4 cubed. What is this? Why is it popping up? Okay. Just whatever root it is, whatever is in the index spot. All right. X doesn't have an exponent, so I put what?
1.
Ooh. And converting it to exponential form, it becomes x to the power of 1/4. 6. 2 needs an exponent of
1.
Converting it to exponential becomes 2 to the power of 1/4. We're not going to keep putting this in the calculator because by now you should know You're gonna get the same answer, just two different ways of writing it, okay? Look at number 7. This time 4 already has its own exponent. So when we convert it to exponential form, it becomes 4 to the power of what? 3 over 5, inside over outside, 3 over 5, inside over outside. Look at 8. How many powers do we have under the radical symbol?
3, bro.
3. But since they're all under the radical symbol, what have we learned that helps us keep them together?
Fraction.
Just think about that.
Breaking apart.
2 needs an exponent of,
1.
x needs an exponent of,
1.
and y needs an exponent of.
1.
The index is
2.
2. If there's no number in the index spot, that is a 2. Making this 2 to the power of
1, 1, 1.
1/2, x to the power of, and y to the power of. Now, we have learned in the past that there is a way to make this, to write this faster, to make it shorter, to make it easier. There is a way to take that 1/2 and apply it to 2x and y at the same time, but we will need what symbol? What symbol will help us distribute or multiply that 1/2 by each one? Parentheses. Another way to keep them together even after I remove them from the radical is to use parentheses. Because if I put them inside parentheses and I put the 1 on the outside, that means this exponent of 1 applies to the 2, it applies to the x, and it also applies to the y. So I can do the same thing in exponential form, 2xy to the power of 1/2. Now the 1/2 is on the 2. Technically, it's also on the x, and it's also on the y. Faster way. Neither one of these is wrong, but this would probably be the way you would want to go. Okay. 9. What's different about example 9? Not everything is under the radical. There's 1 on the outside. So where do you think that 12 is going to go?
Front. Front of the parentheses.
In front of the parentheses, outside of the parentheses. And because we want to keep x and y together, I'm going to go ahead and group them with parentheses and put an exponent of 1, making this xy to the power of 1/6. Number 10. Number 10 is similar, but not the same. This time we want to make sure to group all my powers together. So I'm gonna put parentheses around everything and give each one the exponent of
1.
Making this in exponential form, 12xy in parentheses to the power of 1/6. Notice the difference of when to put everything in the parentheses and when to not. Everybody see that? All right. That was the bell. Next. Now we're going to work backwards. This time we're going to start with exponential form and put it back under the radical symbol. So I'm going to start by drawing my radical symbol. What goes inside? 75 to the power of, and what number on the outside? Now, technically, do you need to include that exponent of 1?
No.
Do you need to include the 2?
No.
No, because even if it's not present, it is understood to be there. The 1 is understood to be there. The 2 is also understood to be there. Okay. Number 2, what goes under the radical symbol? 125 to the power of, with what number in the index? 5. Inside over outside. Questions so far? Now we have parentheses. Now we need to worry about what goes inside, what doesn't. Okay. So number 3, draw your radical symbol. What goes inside the radical symbol? 15n. I want to keep them together. So I'm going to just go ahead and keep them in the parentheses. Exponent of 1. What index? Index of 4. Index is your outside number. Now 4 is similar to 3, but not the same. That 1/4 only applies to which base? It only applies to n because the parentheses is what causes this 1/4 to apply to the 15 and the n. But here, 1/4 only applies to the n. So where's 15 gonna go? Outside of the radical symbol. So 15 to the 4th root of n to the power of 1. Once again, not required to include the exponent of 1, but you are required to include the 4 for your index. 5. 5 and 6 are similar, not the same. For 5, what do we put under the radical symbol?
25.
To the power of 1. And what's my index? Number 6.
So 25 goes in front of the thing.
What is it called?
Radical.
225 goes in front of the radical symbol. What goes under? XY to the power of. And what's your index? Good. Pretty straightforward, right? Wow. 7 and 8. You should be scared. 7 and 8. Radical symbol. What goes inside the radical? 16ab to the power of index of. Okay. Number 8. 1/3 only applies to what?
B.
Good. It only applies to B. So what goes in front of the radical?
16A.
16 and A. By this example, I always have one student or two students ask, so does that mean that all letters go under the radical? Not true. What goes under the radical is what that exponent is applied to, and that was only B. B to the power of 1, index of 3. 9. What goes in front?
4H.
And what goes inside of the radical? To the power of?
1.
An index of? And last but not least, what goes in front?
4.
What goes inside?
HK
In parentheses, because we want to keep them together. Or you want the 1 to apply to H and K with index of 7. And we're done. Make sure to glue this into 85.